Dear students, welcome to the problem solving session on continuous random variable part 2. In the first part, we see the definition and properties of continuous random variable, and we have cracked one problem. We found mean, variance, conditional probability and probability of x less than 1 by 2 and x lies between 1 by 4 and 1 by 2. And in today's session, we are going to explore few more problems on continuous random variable. So the given PDF is f of x, that is 3x square, lies between 0 to 1 including 0 and 1. We have to find the value of k such that probability of x less than or equal to k is equal to probability of x greater than k. And the second question, we have to find the value of b such that probability of x greater than b is equal to 0.05. First, let us find the k. Given probability of x less than or equal to k is equal to probability of x greater than k, we know that total probability is 1. Therefore, probability of x less than or equal to k plus probability of x greater than k is always equal to 1. Now, from the question, probability of x less than or equal to k is equal to probability of x greater than k. Both are equal. So, I am going to rewrite this as 2 times probability of x less than or equal to k. Therefore, probability of x less than or equal to k is simply 1 by 2. Next, we are going to find the k value. So, when we say probability of x less than or equal to k, then the formula is from minus infinity to k f of x dx. Now, according to the problem, that is equal to 1 by 2. But our function f of x lies between 0 to 1. Therefore, my lower limit is going to be 0 and my upper limit is going to be k. Substituting the f of x value and the limit 0, we get integral 0 to k 3x square dx. Integrating this, we get 3 into x cube by 3, limit 0 to k, that is equal to 1 by 2. Now I can cancel this 3 and substituting the value of k, we get k cube is equal to 1 by 2. K is equal to 1 by 2 whole power 1 by 3. I am taking cube root on both sides. So we found the value of k. Next we have to find the value of b for the given relation probability of x greater than b is equal to 0.05. So according to the definition, if x greater than b, from b to infinity, f of x dx is equal to 0.05, but our function x lies between 0 to 1 when f of x is 3x square and 0 otherwise. Therefore, integral b to 1 3x square dx is equal to 0.05. Now integrating this, we get 3 into x cube by 3. Cancelling this 3 and substituting the upper and lower limit, we get 1 cube minus b cube is equal to 0.05. So 1 cube is 1 minus 0.05. I push to the left hand side is equal to b cube. Therefore, b cube is equal to 0.95. b is equal to 0.95 whole power 1 by 3. I am just taking cube root on both sides. Therefore, we found the value of b. Hope you understand, students. Next, we are going to see one more interesting problem. For a given random variable, f of x is equal to k into x square e power minus x. All the previous problem, we saw we have only one function. But here, we have a function which is x square multiplied with e power minus x. We have to solve the problem with utmost care. We have to find k value first, mean, variance, and then e of 3x square minus 2x. So let us crack one by one. First, we have to find k. We know that total probability is always 1. So integral minus infinity to infinity f of x dx is equal to 1. For our problem, it is mentioned that x greater than or equal to 0. So we can take this as 0 to infinity k into x square into e power minus x dx is equal to 1. Now I can take this k outside. I have to integrate this problem. You see here x square into e power minus x. So I don't have any direct formula to solve. So I am going to get the help of Bernoulli's formula. For Bernoulli's formula, one function should be diminishing and the other one is non-diminishing. Here x square is diminishing because differentiation of x square is 2x, then differentiation of 2x is 2 and differentiation of 2 is 0. Hope in the previous semester we used Bernoulli's formula in many places in Fourier series and wave equations to solve the problem. So just recall the Bernoulli's formula. Integral u dv is uv minus u dash v1 plus u double dash v2 etc. So now x square is diminishing and e power minus x is non-diminishing. Now we have to find the derivative u dash, u double dash etc. till it gets 0. So u dash is 2x, u double dash is 2, u triple dash is 0. So after this all the terms are going to be 0. Now we have to integrate this. Integrating dv we get v, then e power minus x integration is minus e power minus x. Now integrating v we get v1, we'll get one more minus, so minus into minus it will become plus e power minus x. Then v2 is e power minus x divided by minus 1. Simply we write this as minus e power minus x. Now this is ready. I have to substitute this in the formula. We can see uv, u dash v1, u double dash v2, then remaining all the things are 0. Now using Bernoulli's formula, I am going to find the value of k. K into uv, that is x square into minus e power minus x minus 2x into e power minus x plus 2 into minus e power minus x, limit 0 to infinity, that is equal to 1. And we know the basic result, e power 0 is 1, e power infinity is infinity. So obviously e power minus infinity is 1 by e power infinity, that is 1 by infinity. So it is going to be 0. When I substitute my upper limit, all the terms are going to be 0 because of this e power minus infinity. When I substitute the lower limit, this term will become 0 and this term will become 0 and we have only the last term exists. So k into 0 minus of 2 times minus e power 0, that is equal to 1. So it is simply k into 0 minus of minus plus 2 is equal to 1. So 2k is equal to 1. Therefore my k value is 1 by 2. So we found the k value. Next we are going to find the mean. We know that e of x is integral minus infinity to infinity x into f of x dx. Since x greater than or equal to 0 according to our question, my limits are going to be 0 to infinity. For this my f of x is k into x square e power minus x. Just now we found k is equal to 1 by 2. Substituting all these things here, we get 1 by 2 integral 0 to infinity. This x into x square is x cube e power minus x dx. Again we have to apply Bernoulli's formula. So we take u as x cube, dv as e power minus x, u dash is 3x square, u double dash 6x, triple dash is 6 and fourth derivative will become 0. Similarly, when I integrate dv, I get minus e power minus x, v1 is plus e power minus x, v2 is minus e power minus x and finally v3 is going to be e power minus x. Now using Bernoulli's formula, I can just club this content. Substituting this, we get 1 by 2 into x cube into minus e power minus x etc. Just substitute this and my upper limit is infinity and my lower limit is 0. As I said, e power minus infinity is 0 and e power 0 is 1. It is very obvious all my upper limit will become 0 minus, when we go for lower limit, 0 minus 0 plus 0 minus 6 into e power 0. So we get 1 by 2 minus into minus plus 6. Therefore my e of x is going to be 3. So we found the mean is 3. Next we have to find the variance. To find the variance, the formula is e of x square minus e of x whole square. We have e of x in our hand. We have to find e of x square. It is obvious e of x square is integral minus infinity to infinity x square into f of x. Since x greater than or equal to 0, I can write this as integral 0 to infinity x square and the function is k, that k value is 1 by 2 into x square e power minus x dx. So I can take this 1 by 2 outside and then multiplying this x square with x square, we get this. Again we have to apply Bernoulli's formula and it is not very tough. You see here, x power 4 differentiation is 4x cube. 4x cube differentiation is 12x square. 12x square differentiation is 24x. 24x differentiation is 24, and then we have 1 by 2 outside. So my answer is going to be 12. I can easily guess this, but we have to write in a proper way. So we take u and dv. Differentiating this at the fifth derivative, it will become 0. When I integrate dv, alternatively we get minus plus sign like this. Now we have to map uv, u dash v1, u double dash v2, triple dash v3 and fourth derivative with v4, and rewriting this, since we know that e power minus infinity is 0 and e power 0 is 1, except the last term, all the term will get diminished. It will become 0. Therefore, e of x square is 1 by 2, 0 minus of minus 24. So, e of x square is 24 by 2, that is 12. So, we found e of x square is 12. Next, we have to find variance. E of x square is 12. E of x is 3. So, e of x whole square is 9. So, 12 minus 9 is 3. Therefore, variance of x is also 3. Next, we have to find e of 3x square minus 2x. Applying the applying the linear property, we know that e of ax plus or minus b is equal to a into e of x plus or minus e of b, that is nothing but a into e of x plus or minus b. Since e of x satisfies linear property, we know that e of ax is equal to a into e of x, where x is the random variable and a is the constant. So e of 3x square minus 2x is equal to 3 times e of x square minus 2 times e of x, and e of x square value is 12 minus 2 times e of x value is 3. So we get 36 minus 6, that is 30. Hope you understand, students.
Thanks for watching. Hope you found this video helpful. Subscribe to our channel and share it to your friends. See you in the next video. Bye bye.